Welcome to the Future Space and Polish Space Agency podcast. Future Space is a European Union Erasmus Plus funded project for astronomy and space exploration in educational systems. We aspire to provide a catalyst for change in understanding and teaching science, technology, engineering and math in upper secondary schools in Poland, Greece and in the Netherlands. Sit back and enjoy our podcast.
Hello, ladies and gentlemen. This is Paweł Uszyński, Paweł Uszyński from Warsaw, Poland speaking, and this is the first of our podcasts for POLSA, Polish Space Agency, Polska Agencja Kosmiczna. We're gonna talk about space and Earth in space, how it exists in space, what's important for Earth in space, and we're gonna talk to people who take care of Earth in space, so to say. I hope you enjoy this mini-series. I hope you were fine with the questions I'm gonna ask and you find them interesting. And first of all, that you're gonna find interesting and fun our experts who gonna speak to us today, which are Kleomenis Tsiganis from Greece and Mikołaj Krużyński from Poland. Kleomenis, can you introduce yourself?
Yes, thank you, Paweł. My name is Kleomenis Tsiganis. I am a professor of dynamical astronomy in the Department of Physics at the Aristotle University of Thessaloniki in Greece. So my main field of expertise and the problem that I most love working on is asteroid dynamics. Why they are moving as they're moving, are they approaching the Earth, is that a problem, and all these fun questions.
Okay, great. Mikołaj.
Yes, hello, good morning. My name is Mikołaj Krużyński and I am an SSA specialist and I work in Polish Space Agency and I am a member of SSA team, and I say SSA many times, so I will say SSA is a space situational awareness, so a part of, let's say, space safety area, and I'm involved in everything what is about artificial satellites and space debris.
Okay, so guys, you're the specialists in keeping, and that's, I said this on purpose, you're the specialist to keep Earth somehow safe in space, am I right?
Yeah, exactly. We care about safety, but not safety on the ground and dangerous from the ground, but from the space.
Yeah, and okay, I thought I'm gonna ask this question later on, but I really feel like jumping into it. You know that I recommended you a movie called Space Sweepers. Okay, that might be silly, but it's a sci-fi movie. But did you see this by any chance?
No, I haven't.
Not at all. I haven't.
No. Okay, so I'm gonna give you a very brief description. It's a future of Earth, and the space is full of debris around Earth, and there are special guys who are actually cleaning up the space. It's their job to clean up the rubbish in space. It's so much of it out there that they have to take care of it. It's a great adventurous sci-fi movie. And okay, this is kind of an apocalypse times like, but it's kind of comedy funny style, but it's apocalyptic actually. And tell me, is this possible that if we don't take care about space debris and near-Earth objects, our closest orbit may become such rubbish one day? Kleomenis.
Yes, and I'm sure Mikołaj can attest to this too. It is certain that we need to take care of this thing. Mm-hmm. Now, as for natural objects such as near-Earth asteroids, the danger for spaceborne systems, satellites, communications, and things like that, is actually smaller than the danger posed by the debris that are left there by man-made missions, as Mikołaj can attest. For the near-Earth objects that come from space, natural objects, of course, there are small meteorites. We always have to take this into account, but this is actually a small fraction of the objects that are dangerous for the active satellites. However, from time to time, we do have also natural objects, big objects that come close. For example, one of the famous near-Earth asteroids named Apophis,
Mm-hmm.
who just swung by the Earth about 1 million kilometers away a few weeks ago, is going to come back again in a few years, passing essentially between the Earth and the geostationary satellites. This is really, really close.
Oh, yes, it is close. I can imagine.
We hope that it will be safe enough and no satellite will be swept away, in fact, during this encounter. But this just gives you an example that from time to time, we do have to worry also about natural objects, for which, to be honest, we actually worry much more if some object like that will fall on the Earth. But we also consider space systems.
I get it.
But the danger for space system is certainly larger if we don't take care of our rubbish, as you would say, and I'm sure Mikołaj can add to that.
Yes, actually, that's maybe my second thing. But, I just wanted to ask you one more, like to make it precise, because you're talking about near-Earth objects. And talking about this, these are natural objects, I suppose.
Yes.
NEO abbreviation stands for natural near-Earth objects, right?
Near-Earth object. Yes, of course. They are.
So everything that passes by, we sometimes read or see in the media do write about this, that an asteroid is going to come close to Earth. It's like once per some months or weeks, we got the news in the media that something's passing by. And you're one of the people who's supporting actually the media with the news of that kind. Am I right?
Yes, to some extent, yes.
Yes.
Yes, but
you're
the
source.
Question,
you're the source for this information.
The near-Earth objects are all natural, and in their vast majority, they are asteroids. So this simply means they originate between the orbit of Mars and the orbit of Jupiter.
Okay.
This is the reservoir of the biggest reservoir of natural objects, asteroids, in the solar system, at least in the inner solar system.
Okay.
But from time to time, there are objects who actually leave this area on a, let's call it, uncontrolled flight and come close to the Earth.
Mm-hmm.
When they do that, they are then labeled as near-Earth asteroids. And if we spot such an object, we monitor it because their orbit is highly irregular, because all the planets in the solar system are actually pulling with their gravitational pull from here and there. The orbit is very irregular. It can swing by the Earth far away or very close. It can fall on the Earth or another planet, or it can fall on the Sun, or it will get lost eventually from the solar system by being ejected.
Okay. Yes. Okay. Kleomenis, let's get back to it in a minute.
Sure.
This is totally on my list of questions to you. But, okay, so we have separated. We have near-Earth objects that are natural, and we have space debris. And this is, as I understand, Mikołaj, this is your field. All the human-made objects that can turn into space debris once, right?
Yes, exactly. This is my field of interest, and the space debris. It's not such a big problem, but the vision you talked before, it's the pessimistic version of our future, because yes, now we have about 25,000 objects around the Earth, orbiting Earth.
How many? 25,000 human-made objects in space?
Yeah, exactly. And this is only objects which are catalogued, so with the size bigger than, let's say, 10 centimeters.
Exactly. Yeah. Let's be precise.
Yeah.
What's the minimum and maximum size of the objects that we know human-made that are there? What's the smallest one and the largest one?
The smallest one, of course, there are some objects with the size microns, millimeters, but we can observe object which size is bigger than, let's say, 5-10 centimeters. The smaller one we cannot see. And the biggest one, there are objects which has in size, let's say, 20, 30, 50 meters long, for example.
But this is not debris.
Sometimes there are debris because
50 meters long trash in space?
Exactly. Let's imagine.
Where does it come? Okay, where does it come from? Like a 50 meters object that's there, like it's rubbish. I didn't know it can be that big.
I can give you an example. What was the first object, what is the first object in space catalog, American space catalog?
I have no idea.
Almost everyone say, oh, it has to be Sputnik, the first satellite. No, the first object in catalog is the rocket which lifted off the Sputnik. And this is the first space debris.
This is pure logic. It's logical. This rocket simply left space to orbit Earth. I didn't know. But when I think about it, wow. And the rocket that lifted Sputnik is still there as space debris.
At the moment, it fall down. It fall down. It's not in the catalog anymore. So sometimes this object go back to the Earth. We can say about re-entry event at that moment. But a lot of objects still orbiting Earth.
Okay, and what kind of a threat does it pose to us when this object falls down? And does it happen often that something that is debris falls down?
It was about 100 re-entry events in 2021, but only...
Oh, wow.
Yeah, but most of the objects are very, very small, and they just disappear. They burn in atmosphere. But some of them, as the Long March 5B rocket, we can hear about this last week.
Yes.
Yeah, this was a big object, more than 20 tons. So it fell down, and it wasn't burned for all in atmosphere, but some fragments go to the Earth, to the surface of the Earth.
This rocket, this Chinese rocket, is a very good example of an object, of a large new space debris, because it was space debris when it was there for a couple of, days, right?
Yeah, it was space debris for about 10 days, yes, but it was a huge problem because the re-entry was uncontrolled, and we didn't know how it go into atmosphere and what will be the dangerous.
Yeah, where did it fall finally? Because I don't even know.
At the north, let's say, of Indian Ocean.
Ooh.
So hopefully it fall down to ocean, not for the city or anywhere where people live.
This is the Future Space Podcast.
Good. Okay. Miniaturizing the chips, the electronics, all the mechanism. Well, we're developing technologies in time simply, so we don't have to send a bus.
Yeah.
We can send the cube.
Polish students sent such satellite to the orbit to test some systems to deorbitize the satellite.
And a bunch of our students are now preparing their own, which has been selected by ESA. So there are a lot of student teams who are actually doing great work on these things.
Yeah, so maybe let's get into this. Thank you, Mikołaj. I'll get back to you with the same very question in a minute, how it looks like in Poland. I would like to know how it looks like in Greece, in your university or generally. Young people that want to study your areas, your fields, your sciences, actually, what should they do, like maybe on the high school level, what to take care of, how to prepare yourself, what to really study most, I don't know how to say this, and how to help yourself in high school?
Well, in Greece, what's happening is that basically students who are finishing high school, they are already oriented towards either sciences and STEM in general, or towards classical humanities and things like that. So those who study sciences will actually enter the university and choose one of the major disciplines like physics, which is the basic route to space sciences, or engineering. So we have a lot of people and we collaborate a lot also with students coming from the electrical engineering community, because this is the other main pillar of the space technology, if you like, discipline. So the question has an easy answer, which is the same, that unfortunately high school teachers would give, since 50 or 100 years ago: physics, mathematics, chemistry, and nowadays in informatics. And that's it, right?
Let me just ask Mikołaj, how to help yourself in high school when you want to start a career and studying anything about space debris?
The people I know starting in astronomy somehow with first telescope, with some observations. I went for my first scientific camp, let's say when I was 16. And after this, I was studied mathematics, physics at high school, and after that, the engineering studies or astronomy studies. This is the way how I go to space debris. I studied automatics and robotics, and I always were very interested in astronomy, and I find out, how to connect it. Yeah,
exactly. Next natural connection.
Engineering, astronomy, satellites. So it was a natural decision for me to go in this topic, because there is also a lot of technical things around this. For example, observations, robotic telescopes, robotic observatories, planning the observations. All these things need some background, engineering background, technical background, mathematics, physics, informatics. All these things are connected in this area.
So there are many specialists needed of different kind in both your Mikołaj and your Kleomenis, in your areas. And as we still send satellites, and we're going to send more and more of them, and as still there are near-Earth objects, you're going to keep yourself busy. I mean, you're not going to be unemployed. That sounds good. Okay, I feel like getting back to Kleomenis and asking you this, because now we started talking about, okay, this is danger. This is what you take care of. For human-made objects and natural objects. So I have a very certain question. What actually happened in Chelyabinsk in 2013? We saw a lot of footage there on YouTube, like it was this massive, very well-known, also in the media, social media event. What was it?
It was a large meteorite, what we would call a bolide, in fact a super bolide. Super bolide is something that when it enters the atmosphere, it becomes brighter than maybe even 100 times the brightness of the moon, right? Because it is something relatively big, very fast, that it actually burns in the atmosphere because it has a shallow angle at which it enters. And because of the friction with the atmosphere, it starts burning. Its temperature is increasing, and at some point it detonates. It becomes an air burst, as we call it. And this is what Chelyabinsk was. I think that it was even bigger than what we would normally consider as a substantial episode, because it was in the morning when people were getting to their jobs. It was close to a well-populated area, and also because on the same day we were actually expecting another near-Earth asteroid to pass by on the opposite side of the Earth. And people were actually getting ready to observe another near-Earth asteroid passing by. And on the same day, a few hours earlier, if I remember well, the Chelyabinsk meteor actually fell.
So you did not actually expect it?
No, not at all.
Okay, so still this is the matter of developing more technologies, more observation points, and simply hiring more people, let's say, right?
Well, there are several layers of problems there, in fact. Because first of all, it was small. In this size range, 20 meters or so.
Exactly. So yeah, let's
try to be specific if you want.
Yes. What size was it, and what was the speed of it?
It was about 20 meters diameter, traveling at about 20 kilometers per second. Okay, this is very.
It's
big.
a massive bomb.
Yes. Yes. In fact, if you want to count in terms of bombs or energy, the energy that was released and absorbed by the atmosphere in the detonation, it is estimated that it was around 5,000 kilotons of TNT equivalent, or if you like, 30 times the Hiroshima bomb. 30 times the Hiroshima bomb. Okay? And it detonated at an altitude of about 30 kilometers from ground with a blast wave that, or if you like, a thermal area in which everything was melting around it, about 4 to 5 kilometers. And the blast wave reached the cities about 2 minutes later. And some parts of it actually fell on the ground, which is when we stop speaking about a meteor and we speak about a meteorite, when fragments reach the surface.
So it's good to know, because I didn't know. I as many people probably, we thought that it's simply then this 20-meter diameter object, it hit the Earth, and it did not.
No, most of the objects that are below 20-25 meters will not hit the Earth.
Okay.
They will enter in the atmosphere and either burn completely, or typically if they're larger and their composition, most of these objects is not really solid metal or something like that. So they tend to fragment by actually exploding. So most of these objects below 20 meters are bright bolides. The smaller ones we simply enjoy looking at. The bigger ones, around 10-20 meters, will actually detonate high in the atmosphere, but with a considerable energy, as I told you. And that can cause problems on the ground by the blast wave, actually. And this is what happened in Chelyabinsk. We had about 1,500 people injured because of smashing windows. If I remember well, an old roof from some sort of old factory fell and people got injured and things like that.
Okay, I get it. Thank you. Okay, Mikołaj, this is what we know about natural objects from Kleomenis, and of course we can observe it, we have no control over it. But for human-made objects, correct me if I'm wrong, we have a satellite. What happens to a satellite after it's out of order, it stops working? Are there ways, procedures for the planned re-entry of this? Because, well, that sounds like solving this problem in a part at least.
Yeah, exactly. Some countries, some agencies require the plan to deorbit the object after the end of its life, so after the end of this mission. And at the moment, we say about 10 to 15 years after the end of mission, the satellite has to go to the atmosphere and burn. But it works only for the low Earth objects, so LEO objects. When we put satellite on a geostationary orbit, it's impossible to get it down.
What is geostationary orbit?
It's a special orbit when the orbital period corresponds with velocity, with a period of rotating the Earth. So
we see the object in one point on the sky.
Yeah, exactly. And because of that, we can have the television from the satellite. Yes. For example, telecommunication, meteorological satellites,
mobile phones.
Meteorological satellites, which can see always, for example, Europe and track the clouds over the Europe. So we can...
Spying satellites have to move quickly.
They are lower. Usually they are lower. Yes.
Yeah, they are lower.
So no, they are not constant on the sky. They can't be.
Exactly.
We have no military and some military counterintelligence intelligence experts here. I wish to hear their voice. But okay, so anyway, Mikołaj, so we can plan. If we have an object that's human-made and we don't want to make it debris, there are procedures and ways to make it re-enter the atmosphere in a planned way.
Yeah, at low Earth object, we have such procedures. And as I will finish about geostationary orbit, there is also a special region called disposal orbits, when we can put satellite after this lifetime, after the life of this satellite. So when the fuel is almost finished, the satellite get a kick and go to a little bit lower or higher than the geostationary plane, geostationary orbit.
And it stays there.
Yeah, and it let's say stays there, yes, for the...
Tell him that we call it a graveyard.
Yeah, we can call it graveyard, exactly.
Okay, is this graveyard safe?
Yeah, it's safe for the geostationary ring, and at the moment...
Because this also behaves the same way. It's geostationary, so it doesn't change its position, so it's not going to start colliding.
Yeah, exactly. But of course, the volume of this graveyard also is somehow limited. At the moment, we don't have this problem, but
we still need to see some sun.
Yeah, exactly.
Not only like dotted. Yeah.
After 100, 200 years, we still will have a problem.
We will have to clean it all up. Let's hope by then you're going to have all the great technologies that are needed for this. Okay, so but this is all country regulated, and you say so. This is not like there's no like general rules for all the countries that if you put an orbit there, you should do this and that.
There are some international regulations with these things, but of course also any country have some policies about this, and not all countries are using this international policy. Yeah, so it depends. It depends from the country and from the technology which country have, because some countries have the technology to lift off rockets and own satellites, some not.
Just one very short question before we get back to Kleomenis. Can we lose a satellite? Like, it stopped communicating with us, it's changed its trajectory, anything. Can we lose an object this way?
We can lose the communication with the satellite, and it could be a problem. And we have such examples when the satellite, a scientific satellite, the telescope go to orbit and stop the communicate with the center. And we lose this object. Yeah, we lose this satellite.
Yeah, well, you lose it, but you don't lose it on the map. You still have the insight into where is it, how it behaves, what's the trajectory and stuff.
Yeah, exactly. We can observe it. We use telescopes, radars, lasers to do the observation and to build a catalog of the orbits.
Yeah, so it's possible to lose the contact, but it's actually quite hard to lose the object itself.
Yeah, but imagine that the satellite is hit by the small debris. Small debris, yeah, but it has velocity about 7 kilometers per second. So 10 times faster than the bullet from machine gun.
So it's exactly that's what I wanted to say. It's like a space machine gun burst.
Yeah, exactly. And the satellite can be damaged, or it can start rotating, for example, because of the heat, and we cannot stabilize it, and we lose it again.
Yeah, then you can only observe.
This is the Future Space Podcast.
Okay, Kleomenis, I know a lot of new things, and our listeners know a lot of new things about human-made objects and trying to control them, observe them. But actually, how do you search for NEOs, for near-Earth objects? What's the technology there?
Well, the technology is, as usual in astronomy, for looking for near-Earth objects, you just scan the sky with telescopes. Telescopes equipped with good cameras that could record thousands of images per night. And then by comparing them, you're trying to find objects that actually move with respect to the distant stars. And then there is a catalog similar to the catalog that Mikołaj mentioned about space debris. We have a much bigger catalog for asteroids, actually, and other objects that float around the solar system. And we compare our detections to see if it is a known object or a new object. Mm-hmm. Then there is let's call it the survey mode and the discovery of new objects. And then we have the phase of what we call follow-up observation, where different observatories would just follow up on the newly discovered objects in order to collect more measurements so that we can estimate their trajectory with very good accuracy. Mm-hmm. Then we will know if it's a near-Earth object or not, if it comes close, how close, and so on. Then we go into our computers to compute the orbit, to propagate into the future, so that we know if it is a good behaving orbit or it will collide with the Earth and so on. And typically what happens with near-Earth asteroids is that in the beginning of these phases, the knowledge of the trajectory is relatively poor. Oh. It's not of high precision, not of high quality. So you can get, let's say, an asteroid with 2 or 3% probability of hitting the Earth within 50 years. This is a nightmare, right? 1 or 2% or 0.1% is a huge number to leave it like that. Mm-hmm. So these objects are flagged as potentially hazardous, and you double your efforts into monitoring them, getting more observations, doing the calculations again and again, in order for them to drop down below a given threshold of uncertainty and risk.
Yeah, so I hope your work is not a nightmare, and then you can still sleep at night, and it's good that you took this responsibility for all of us. But
this is great.
Yeah, it's fun, right?
Yeah.
Still, keeping people safe. It's like space police.
Exactly.
Of some kind, for of course, not for other people or aliens, but for simply non-living nature, let's call it like this.
Yes.
Yes, but let's make it really scientific. Let's make it finally proper. Let's listen to specialists.
All right.
If there's an object heading Earth and it's got 100 meters diameter,
all right,
can we do anything right now to stop it, to change its trajectory, to change it into smaller objects? And if not, are we working on this technology? When would it be available?
Yes, we can. We believe we can. And we're going to do the first experiment starting next year. Just to put it a little bit in context, those that are big, let's say 1 kilometer objects, you would probably try to do it with nuclear bombs or whatever, which is much more dangerous. In fact, if it detonates before it reaches the target, that's it, right? And so it's a good thing that we know we're not in any real danger from these big guys, actually. But for those who are actually worrying us about 100, 150 meters, we believe that the most efficient technology is the simplest one. You take a big rocket, if you like, or a spacecraft, which is, let's say, 500 kilos, 1,000 kilos. You accelerate it as much as you can, and you simply hit the asteroid.
Crash it.
The asteroid doesn't feel anything. It's like a mosquito falling on the back of an elephant or something at high speed. Maybe it would be a bit more painful if the asteroid could feel something. However, we do not expect actually to break it. What we expect is to change its velocity so slightly that you wouldn't even see it by a telescope. Let's say on the order of a few centimeters per second. But nature is also nice sometimes. This little deviation, as we call it, is enough because of the fact that these orbits are highly irregular, what we call among ourselves chaotic, and this has a very particular meaning in mathematics. It means that any small kick that you give will grow exponentially in time, very fast. So if you have a few years before impact, let's say 4 or 5, the typical time you need to prepare a mission, and you hit it with a spacecraft, this is fine. It will be deflected as much as you need in order to avoid the Earth. However, this is all in paper until now, and there is a plan to do it for the first time in history. Man will try to change the orbit of a near-Earth asteroid. We're not in danger from the asteroid that is actually called Didymos, because it's not a single object. There are 2 objects orbiting around each other, and they're named Didymos because this is the word for twin in Greek, like twin brothers.
Yes.
Anyway, this is a near-Earth asteroid that will come by the Earth in 2022, around October 2022. It's harmless, at least for the time being. And we're just gonna hit it because we can. It's a very good target by all our measurements. And we're gonna try to see
what's up, what happens. Yeah, so, okay.
In fact, we're gonna do the experiment on a smaller scale, in fact. Because the object is double, so there is a small one orbiting a bigger. The small one is about 130 meters, the size we want to test. And by hitting it with a spacecraft, we will only change the orbit of the small guy around the big guy by a few minutes, the orbital period. But this would be enough if we observe it.
All right. Okay.
I should say that this is what we call, this is a mission that is going to develop in 2 phases.
Mm-hmm.
So around, if I remember well, October 2021, NASA will launch the DART spacecraft, which is the projectile. A year later, it will actually hit the small of the 2 Didymos asteroids. We will have the first observations by telescope, and then a couple of years later, a second spacecraft called ERA, the HERA mission, organized by the European Space Agency, will actually go and catch up with the same binary asteroid when it passes again from Earth in 2026, so to examine closely what happened during the impact. It is only then that we will have all the scientific information we need to have in order to make sure that it worked as we wanted or not, and that we could repeat that and do it even better and do it for different types of near-Earth asteroids.
Guys, you sound like you're really very, very precise in what you do. Wow, this is kind of amazing. Let's get back to Mikołaj, who's not bored, I suppose, I hope.
Of course not.
Listening to all this. For me, this is all, guys, what you're saying. It's absolutely stunning, fascinating. I wish I was 20 years younger to start a new career in astronomy, space debris, NEOs and stuff. Okay, Kleomenis, everybody talks until now about Tunguska event. Like, I think everybody knows it. And I know, Kleomenis, this is a cliche.
No, it's fine.
But I'm gonna ask you, because people know that Siberia 100 years ago, something large impacted the Earth, and that's it, we know nothing more. So maybe you could clarify a bit and provide us with any detail. Do you know any details about it?
Sure. Well, the Tunguska event, which happened on the 30th of June, 1918, if I remember well, it was, if you like, the big brother of the Chelyabinsk meteor. Okay?
Mm-hmm.
So what happened was that a big object on the order of about 100 meters, actually in size, what would be devastating if it would actually fall on the city, fell in the middle of Siberia, in a forest land, essentially, and something about 80 million trees actually were taken off their roots and fell on the ground, burned on one side from the blast wave of the detonation of this object. Again, there is no impact crater. The object never hit the ground.
So again, it exploded.
Yes, it exploded
Oh.
higher at around 10 kilometers, if I remember well, somewhere between 5 and 10 kilometers. And it actually released an energy which was much bigger than the Chelyabinsk. It was on the order of about, let's say, 1,000 Hiroshima bombs.
So it's like a Tsar Bomba once detonated by Soviet Union also.
Exactly.
It's more like
it's
that
almost
size.
exactly the same. It's almost exactly that size. Well, we have very rough estimates, I would say.
Okay, yeah, sure.
Now, it actually caused a seismic wave on the order of 5 in Richter scale.
Yes.
And the thing is that the area was not able to be visited. We only got pictures of it a few years later, in fact. So we don't have first-hand testimonies because very few people were living there, and they never got a chance to actually spread the news, if you like. Learned about
so yeah, it
later.
was hard. Why didn't everybody go there? It was like it was not accessible. Simply, no roads and no stuff.
At the time, it was not accessible. Yes.
All right.
And then a few years later, people went there, took photos, and they realized the size of the devastation.
So what was the diameter?
Again, if it was over a city, it would actually kill the city, right?
We had some luck.
Yeah.
And please estimate for us. What was the diameter of the trees burned? Like probably in kilometers, right?
It was, I think, about 2,000 square kilometers.
Oh my.
Yeah. So something, let's say, on the order of 50 times 40 kilometers.
So it would evaporate every city.
Oh, yes. If it fell on a city, that would be a total disaster.
Yeah.
This is why the objects on the order of 100 meters we call city killers. Right? But this is very rare.
You call it... Okay, Kleomenis, it's been great talking to you. I need you to go back to work like right now because I'm not going to sleep. So
no, this is very rare. Let me give you the scale. Something like Chelyabinsk, which had injuries but not a great disaster, happens, let's say, once every 50 years. That's the estimate.
Mm-hmm.
So it's not very rare. Something like Tunguska, the original estimate was something like 1 every 300 years, maybe 1 every 500, 600 years is the correct estimate. But it is not very small, not negligibly small for human history, right? So the question is, if you have the technology and you're able to defend yourself against it, of course, you should be ready to do so. And this is why we're doing the experiment that I described before.
So if you're not gonna even I'm safe with my lifetime, I still need you to get back to work, to create technologies, to develop, to make catalogs, because it's important, guys, that you keep on working in what you do. So
yeah, you need a system ready. Also because, I mean, these are statistics, right?
Yeah.
The fact that it happened 100 years ago and the mean frequency is every 500 years doesn't mean that it won't happen.
Exactly. I mean, guys, just making, let's sum the things up. I think you're really doing a great job for our planet, for science. And what you do, people don't know about people like you. I don't want to call you heroes, because what you do is that you're trying to make some models and sciences and engineering to avoid stuff, but possibly you're a group of people, you're representing huge groups of people that really one day may save us. And nobody's gonna know it because nothing bad happened. So guys, you're doing a great job. I hope there are more and more people, young people, being like you, simply doing what you do, and also taking the credit and showing it to the world in podcasts like this. It was a pure pleasure. I enjoyed talking to you a lot.
Thank you very much. Thanks for the invitation. Thanks to POLSA for doing this. It was a pleasure for me.
Yeah, for me also, it was a real pleasure to talk to you and to meet you guys. And I hope it won't be the last moment when we meet each other and we can talk about space topics.
Great. So I hope to see you soon, and all the young listeners, listen, I hope to hear from you soon, because this is just the first episode of this mini-series, and we'll be back with one more episode for you soon. Take care.
This is the Future Space Podcast.